Hi, good day. My name is Biansri Pituno, and now we're going to look at integrating a definite integral by substitution, and here are example. Integral from 0 to 2 of x times x squared plus 2 cubed dx. And we'll look more closely at the substitution. Now look at this. This is called integrand. And that's because this thing between our integral sign and our dx, the integrand is the function being integrated. Now look, now take a look. Notice we have a x and an x squared. X and an x squared. And an x, and this is our clue. We recognize that if derivative of an x squared, that will give us something involving x to the first, so recognizing that one, this is a derivative of the other, or in case of ax is a derivative of x squared, or at least is a constant multiplier of derivative of x squared. That's our clue. That one thing might make good u, and then the derivative of the might be the different part of the u. So give us the clue what we try to substitution when you have one thing and derivative of something that approximately its derivative, then trying things for you. So watch this. This is going to be the du, the u is equal to x squared plus 2. Yes. And we, when we do that, we can take that derivative of du over dx. Will be equals to 2x. Now let's solve this. For u will be 2x dx. Now compare this to what we have. We have an original expression. Look here. The x du, the du is equals to 2x dx. Look down here is then the x dx is half of our du. So take note, all of that we have in have a u cube, and the half of our du is, so let's take our original integral and write it the way the original integral is. The integral of x is equals to 0, x is equals to 0 to x is equals to 2 of u cubed times 1 half du, and we can integrate that, bring the 1 half out front, and then we have an integral of u cubed, which is u is the fourth over 4, and we're evaluating this from a form x is equal to 0 to x squared. Writing the x equals here in these places helps realize that we need to substitute back in this u right here. We need to put an expression in terms of x right there for our u. So remember that our u was x squared plus 2x. So let's just plug that back in. This is a 1 half x squared plus 2 to the 4th over 4. And this is now u is a x is equals to 2 and x is equal to 0. So u times 3 1 half of du, and then is equals to 1 half u over 4, u and over 4, and x is equals to 2, x is equals to 0, and then 1 half times x squared plus 2 to the power of 4. Evaluate of x is equals to 2 and x is equals to 0. So, n equals to 1/2 times 6 to the power of 4 over 4 minus 2 to the power of 4 over 4 is equals to 1/2 over 324 minus 4 is equals to 160. So, that's the answer. Substitution with change limits. So what will we do this next time? Instead of substitutioning a right up here this u value with an expression of for x, I'm going to substitute the limits here and make those in terms of u. So same problem will now work with integration, with substitution, with change of limits. So here, this is the integral form of 0 to 2 of x times x squared plus 2 cubed dx. So we start of the same way. We let u is equals to x squared plus 2. And then we can take the derivative of that, and du dx is just 2x. Let's rearrange this du is the 2x dx. So the dx 2x, then du is equals to 2x dx. Note the square, the x squared plus 2 cubed is my u cubed. Then x dx is half of my du. So I'll write this as the integral form of x from x equals to 0 to x is equal to 2. This is the integral form of x is equals to 2 and x is equals to 0. U cubed times 1/2 du. So everything's in the same as before so far. With substitute my limits of integration right now. Remember that u is equals to x, and then x squared plus 2. So when x is equal to 0, so what is u, we'll just put in a 0 right there, and you can see that when x is equal to 0 and when x is equal to 2, what is u is 2 would put in a 2 right there. 2 squared plus 4, 6. So when x is equal to 0, u is equal to 2, and x is equal to 2, u is equals to 6. Can rewrite my original integral now as I'll bring the 1/2 out front, and instead of integrating from x to 0 and x to 2, I'll be integrating from u to 2 and u to 6, and have integral of u cubed and du, and wait, 1/2 integral of u is equals to 6, u is equals to 2 of u cubed du, and then 1/2 over 4. Thinking of u is equals to 6 and u is equals to 2. 1/2, remember, just out from, so now everything's in terms of u, and I can do that substitution even before I integrate. So now the integral of u cubed du is simple. We just do 1/2 times u to the 4th over 4, and evaluating this, u is equal to 2 to u is equal to 6, and now I can do that. I can plug in these values for u, and this variable here, because it's in fact u. So let's do that. This is gonna be a 1/8, just combining the 2 and 4 in denominator. Here, so the 1/8 times 6 to the 4 over 4 minus 2 raised to 4, and then 1/8 over 1, 2, 9, 6 minus 16 is equals to 160. 160. So which is just what we got before. Thank you.